everyone, this is our team Cosmic Crush and we are from Saram Engineering College, Chennai, Tamil Nadu, India. And I'm Sakshi.
I'm Sudarshana.
And I'm Raghav.
As a part of SSCS Arduino Contest, we learned Arduino through the tutorial series and completed every challenge along the way.
In this video, we'll showcase all 10 Arduino challenges that we have successfully completed. Let's get started.
This is a simple traffic signal system made using Arduino Uno. It uses 3 LEDs, red, yellow and green, which represent the 3 traffic lights. The Arduino is programmed to control the LEDs in fixed sequence. First, the red LED glows tells the vehicles to stop, and then the yellow LED glows indicates how the signal is changing. Finally, the green LED glows allowing the vehicles to move. After that, the cycle repeats continuously. This project demonstrates how the Arduino can be used to automate and control traffic signals. Thank you.
The objective of this challenge was to change the LED's blinking behavior depending upon the state of the push button. Initially, when the push button is not pressed, the LED blinks at a normal speed, and Arduino continuously checks the button's state and follows the default blinking pattern. When the push button is pressed, the Arduino detects the input and immediately changes the blinking speed. As a result, LED starts blinking more faster than ever. Then after I leave the button, the LED starts blinking at a normal speed. So from this project, we can understand how the LED's blinking changes through push buttons and Arduino. Good morning everyone. Our project demonstrates how an Arduino communicates with the external devices using serial communication. The Arduino continuously reads the digital input pin using digital read. When the input is high, it sends high through the serial port. When the input is low, it sends low, and the result is displayed on the serial monitor. Thank you.
This project uses a potentiometer to control the LED brightness. As we rotate the potentiometer, the microcontroller reads the analog values and sends it through the serial communication. Based on the value, the LED brightness changes using the pulse width modulation.
Now we are going to see about the interesting project of LED sequence control using a potentiometer. The potentiometer is connected to the Arduino as an analog input. As the knob is rotated, the resistance changes, causing the analog value to vary from 0 to 1025. The Arduino continuously reads this value and compare it with predefined images. At lowest range, only first LED turns on. As the value increases, the second LED turns on. With a further increase, the third LED turns on. At highest range, all the 4 LEDs turn on. When the potentiometer is rotated in the opposite direction, the analog value decreases and the LED turn off one by one.
This project controls the buzzer sequence using a potentiometer. As we rotate the potentiometer, the microcontroller reads the analog values and changes the buzzer sound, pattern or speed. This demonstrates the analog inputs control using a simple and interactive circuit.
Here we have an IR receiver module wired to an Arduino Uno board connected to a laptop by USB. As the buttons are pressed on the IR mode, the receiver decodes the infrared signal and sends the data over serial communication. On the laptop screen, the Arduino serial monitor prints out the raw signal values and decodes the specific button presses, such as channel, volume, and play pause in real time. This setup features an Arduino Uno connected to a single 7-segment display and a push button on a breadboard. The code automatically cycles through a counter sequence, displaying numbers from 0 to 9 in a continuous loop. When the push button on the right is pressed, it triggers an instant reset function, forcing the count back to 0 before it resumes counting upwards. In this demonstration, a DHT11 sensor measures ambient humidity and temperature and logs the live data to the Arduino serial monitor. The program includes threshold logic set to 25 degrees Celsius. As long as the temperature stays below 25 degrees Celsius, the fan turns off. Once the temperature reading crosses 25 degrees Celsius, rising to 25.28 degrees Celsius, the Arduino automatically triggers digital output to turn the motor fan off.